Okay, real quick, I got to figure out how to use this thing.
Green is go.
Green is go.
Red is back.
Perfect.
And the one with the little light on it.
Oh yeah, we are in action. Laser pointers are ready. All right, so yeah, my name's Alex. Let's see, 6th season being out here. So pretty fun place. I think like many of you, I originally came out here because of the mountains and the high quality snow, but the reason I've stayed is because of the people. You got the people like Lynn Wolfs, Liz Kings, and all of you here that care about snow and avalanches. So thank you all for being here. And yeah, let's get into it. I threw up this photo. Full discretion, this was not when I was working. And just get people psyched. So who's stoked for winter? Yeah, now we're talking. Cool. So just a quick rundown of what I'm going to talk about. I'm going to give some updates on BTEC. And then I'm going to go into kind of behind the scenes of our weather stations and how that relates to forecasts and uncertainty. Luckily, I'm going to tie on a lot about what Dallas talked about and Liz, because they set up a great groundwork to kind of go a little bit more in depth with some of these micro processes that we do at BTEC. In addition, I'm going to highlight some tools available on our website that you all can use, kind of going back to that forecasting 101. And then I'm just going to talk about observations and some upcoming events this winter. So here's our lineup for this year. We got Frank as the director. We got myself, Noah McCorkle, who we just got him a permanent job, which is super exciting. Yep. In a time when working for the government has never been harder. Yeah, Travis Baldwin, he'll be working the National Park Service job. And then new to us is Joey Manship, coming from Utah. So super excited to have him on board. Yep. And then we got Mike Ream and John Fitzgerald, who bring decades of institutional knowledge that's super helpful for our team. So pretty excited for the next winter and everyone we have. So what have we been doing? Well, luckily, we've been working through the whole government shutdown. We got exempt. And so all operations are normal. We've been able to get out to all of our weather stations, get our website prepared, get all of our avalanche education events squared away. And so we've kind of just been on the grind, getting ready for winter, waiting for that snow to fall. And, I kind of threw up this photo because a lot of people are like, oh, I love avalanches. Well, we don't love avalanches, but we love snow. We love being out there. Avalanches are part of it. And they wonder, they're like, well, what does the job actually entail? A lot of electrician work, funny enough. Like being good with your hands in like kind of remote areas, like trying to deal with small scale gauge wires when you're up on the top of a mountain is kind of a tough thing to do. So it's kind of this fun thing in the job that I've learned to appreciate, and I think everyone else that works at our organization really likes doing. It's kind of the problem solving hands-on. So this is kind of going to be the baseline of my talk today. This is the typical workflow that we at BTEC go through. And whether I'm forecasting or Travis is or anybody else, this is the general rundown of how we go through things. So it's kind of the first thing we do is we're going to look at weather stations. So we're looking at raw data and we're compiling all that into the 24-hour data summary, which for anybody here, we call the big sheet. And so essentially, it gives us a really good idea of what's going on in the snow, and we can really focus on that. We're taking that information, and then we're relaying it with our observations, all of our field work, and the history of the snowpack. So everything that's been going on up until that point. So that's your persistent weak layers, your frequency of avalanches, your size of avalanches, all those things. Then you're going to go ahead and we're looking at a weather forecast for that day to try to figure out what's going to happen throughout that forecasting shift. We compile all that data, and as Liz talked about, we throw it into the conceptual model of avalanche hazard, and boom, we spit out a danger rating. Seems simple, right? Yeah. It's taking, like a bunch of people have said, and we actually had the lucky enough chance to get with Lynn last week as a team, and pretty much the consensus of the whole talk with us was taking a complex phenomenon and making it as simple as possible. So, as avalanche forecasters, and as Dallas alluded to, that's our goal. The problem is there's a lot of gray areas, a lot of different colors, right? Lots of shades of blue. So we're trying to do a lot with a little, which I think there's something to be said for, simplifying. So yeah, pretty much the whole goal of this presentation is we're just going to look at a few of the processes behind forecasting to help you all assess that forecast and then make real-world decisions once you're out there. And also, because the most frequent question I get is, how much did it snow? So we all want to know that. So I'm going to go into some kind of talking about our weather stations. So as you saw, we have 7 forecasters. We cover 4,000 square miles. Can't get everywhere. We don't know what's always going on. That's where these weather stations are super critical. BTEC, and specifically the foundation, owns, and we operate 7 snow stations, 6 wind stations. It's also super important to know that we utilize a lot of weather stations from other organizations. So on this map here, you can see all those green stations. Those are USGS snowtail sites. The rest are either BTEC, YDOT, and then I didn't mention it here, but all the ski resorts. So Snow King, Targhee, Jacksonville Mountain Resort. And this map right here is one of the cool tools on our website. You can find it under weather stations. And the thing that I like about this map is you can select specific parameters and you can look at large scale trends of what's going on. So you can see here on the bottom graph, or the bottom picture, we have wind. And so when we have a big wind event, you can pull this up and kind of see large scale what's been going on across our forecast area. And that might help you decide, okay, maybe I want to go further north today. Maybe I want to go further south, trying to figure those things out. So one thing, everyone loves the big sheet and they want to know how much it snows, but I don't think a lot of people know how we actually calculate how much snow there is and how the whole system works. So just to get into it, like to measure snow, we have pretty much 2 things that we're looking at. We have the height of the snow, which we use inches because it's in the US, and then we have SWE, which is the snow water equivalent. And for avalanche forecasters, the weight of that snow is really important because typically the heavier the snow, the more chance there is of an avalanche in a very basic understanding. So what we use for the height of the snow is we use these ultrasonic sensors. And at our backcountry stations, we have 2 sensors. We have an interval sensor and a total sensor. And so if one of them goes gunny, we still have another one for backup. And then we can use them both to correlate how much we think it's going to snow. To determine how much weight that snow is, we use these weighing buckets, which you can see in the picture on the right. We also last year bought a radar sensor. And then we have a really cool tool on our big sheet that is pretty much an algorithm that takes all the data of JHMR from the last 50 years, compiles that with what happened the night before, so RH, temperature, wind speed, and then it gives us an estimate of what we think that snow water equivalent is going to be for the day, which is a really cool product that we use as forecasters. And as I mentioned, SWE is one of the most important things for us to know as avalanche forecasters, but it's the most difficult to measure using these instruments. So it's super important to understand that. Adds a lot of uncertainty to things. In addition, wind, we just use speed and direction, and that's derived from an anemometer. I'm sure a lot of the people here have been up on top of Mount Glory and seen the anemometer spinning up there. So that's how we figure out wind. So kind of one of the cool things we did, weather stations-wise, is we put a new set of stations in near Mount Baird in the Snake River Range. And this has kind of been a pretty fun project because the whole goal of this was if we put a weather station in, essentially it would allow us to start forecasting for the Snake River Range by itself. So it's as a whole new zone. Because it does have a lot of different characteristics from, say, the Tetons or the Salt River Range. And so the wind station, we put at 9,700 feet. This has been fun to look at the data because it's a little bit lower than our other wind stations. Typically, our other wind stations are at like 10,000 feet, and you don't always go up to 10,000 feet on a given day. So it's nice to have something slightly lower. In addition, we went ahead and threw up a snow station. We all knew that it snowed a lot in the Snake River Range, but I don't think we understood how much. So you can see these photos of the station almost entirely buried midwinter. So we had to go back in, dig it out, and literally raise the whole station up. And I just threw this graph in because it compares the total snowfall at this buried station to a lot of the other stations in the Tetons. And the Tetons generally get the most snowfall out of all of our zones. So you can see that compared to Surprise Meadows in the park, pretty close to the same amount of snowfall. So an impressive amount. We learned a lot from this station, and this summer we actually went back in and we moved it slightly, hopefully get a little bit better understanding of where we want that station to be in relation to some wind effect that was going on up there. I also want to give a shout out to WYDOT because they put in the Snake River Canyon River Station, and that was super helpful for us when we did create that new forecast zone. So here's one thing that we did last year that's super exciting. So we went ahead and bought one of these Luft WS100s that we put at the Baird Weather Station. Luckily, JHMR also bought a couple of these, and essentially these are instruments that use Doppler radar to measure the snow water equivalent. So these instruments are super awesome because they give us real-time data that's very accurate. Those weighing buckets I was talking about to measure SWE, oftentimes they're delayed. And so for us, it's really important to know when it started snowing, when it stopped snowing. And this WS100 is great for that. The great part about the JHMR putting a set of stations in with this WS100 is every day they go out and they manually measure the SWE of the snow and the height. And so we were able to do a bunch of statistical analysis comparing the WS100 readings to the manual measurements to the ETI buckets. So big shout out Noah. He's a stats king, so he went through, did a bunch of this. And what we found out with this WS100 is it actually underestimates precip values as the SWE increases. So as we get more snowfall, we actually see that this WS100 underestimates the amount of snow, which is super important for us to know on how these instruments correlate to what we're trying to do as forecasters, predicting avalanches. So here's just some more data. We went ahead and compared the ETI weighing buckets to the WS100, and interestingly, we found that the ETI buckets have a higher mean percent error than the WS100, but there's a larger spread between that error value, which is represented here in the standard deviation. Also, you can see in these lower two graphs, there's a slight correlation with the ETI bucket showing less error as SWE increases, versus, as I said, the WS100 has a higher percentage of error as SWE increases. So we can, kind of what we found out is we were like, oh, one great tool is having one of these instruments at all of our stations, because then we can use both of them in kind of parallel with each other, which has been super helpful for us. Here is kind of just a cool little scenario that we had this year. Shout out to Bobby at JHMR. He put this together. But we had a storm come in that was pretty heavy grapple. And so we looked at the measurements. So the manual measurements you can see here and the bucket were pretty similar. But the WS100, that radar sensor, really underestimated the amount of SWE for that storm. So, you know, certain events like this are really important for us to know so that we have accurate data, hopefully improve our ability to forecast. And one thing that's really cool is we're actually working with the company that makes the WS100 and giving them our practitioner feedback. So hopefully they can improve these instruments so that we can create better accuracy. So conclusions, you know, we found that a lot of these instruments that measure SWE are designed specifically for liquid precip, not necessarily snowfall. There's a lot of money that goes into understanding water, right? From agriculture to water resources, and there's not as much money involved in snow, so these instruments aren't necessarily made specifically for snow. So hopefully in the future we can get some more accurate instruments that give us a better idea of what's going on. And it's also, I think the most important thing about all this is it's important to understand that when we're creating that forecast in the morning and we have a high level of uncertainty with our weather stations, we're going to correlate that into our forecasts by creating a larger margin of safety. So if we wake up one morning and it's snowing really hard and we don't exactly know what's going on with the weather stations, and we might be right on the border of whether we're going to go with a moderate or considerable avalanche danger, we're going to go ahead and probably create a little bit of margin of safety and go with that considerable avalanche danger. So it's really important to understand that. In addition, with these weather stations and just estimates in general, they're just estimates, right? So this forecast, it's your baseline understanding before you go out there, but it's important, like Liz said, actually read through the forecast and look at what we're talking about. If we're talking about a storm slab that's 6 to 10 inches deep, and you go out there and you're seeing slabs that are 14 inches deep, well then you gotta understand that, okay, that's not exactly what we thought was going on, so you can expect to see maybe more dangerous avalanche conditions. So it's really important, as Liz said, don't just scan through it 30 seconds, take the time, read these things, understand them. Luckily last year, if anybody was here, we had a great talk from Pascal Hagley talking about the uncertainty in public forecasts. So for anybody that wants to learn more about this, snap a photo of this. Super interesting paper. I highly recommend it. So some future plans for weather stations. We're just trying to keep the funding coming and keep building new weather stations. We got a big project that we're working on in the Big Hole Mountains. So this week we just got up there, put a tripod in, which is pretty much the structure of the weather station. No guarantees that we're going to have this done by this winter, but we're just continuing to try to work on it. And we're just going to continue to try to build new weather stations in places where we have, lacking any sort of data. We're also working with partnerships with other organizations. Recently, we've been working with or chatting with people at Trout Unlimited. They want to figure out a bunch of information related to the Snake River, and so we're looking to partner with them to get some funding. And then we're just looking for any sort of continuing technology upgrades. One of the big projects we're looking at is converting all of our weather station communications to satellite. Right now we use radio and cellular data, so satellites are a little bit more accurate and consistent. In addition, we're looking at using the Snowdar depth sensors, which uses LiDAR technology. We're also looking, we just bought one of these Ventus X wind sensors, and that uses ultrasonic data. So just continually trying to upgrade our technology to get things more accurate. Here you can see a photo of Angle Mountain. We went ahead and installed one of those WS100s up there, so you can keep an eye out for that when you're looking at raw data. So going back to this workflow, we talked about weather stations, why that's important. Now I'm going to dive into observations a little bit deeper dive into some of our stats that we found this winter. So as we've already talked about, observations are critical, right? The more information we have, hopefully the more informed we can all be as a community. I went ahead and threw together this little, I call it the web, but it kind of just shows how the whole snow community is connected. And the way I like to see it is we're all connected kind of through our website and observations. Because regardless of whether you're in a ski area or whether you're a guide or a recreational user, those observations are going to help inform your decision making when you go out in the field. So I really try to focus our attention on the website, because to me that's the most important thing that we do. It brings this whole community together. And so the one thing I say is observations are really important for forecasters, but they're important for everyone else. So here are some stats from last season. This is just public observations per individual. And what we found was there was one person that did 10 or more observations, 8 people that did more than 5, and 24 people that did more than 3. Now, I'm no rocket scientist, but I think we can do a little bit better than this. Because how many months are there in a winter? Can anybody tell me? 5, roughly, right? So if you submit one observation every month, and there's probably 100 people in here, we could bump that number up significantly. So I'm all about accountability. So let's try to, as a community, submit more observations because it helps everyone out, not just forecasters. There's my spiel. Here is some more information. So you can see our observations broken down by forecast zone. So we get 70% of our observations in the Tetons. And so really, if you're recreating in our other forecast zones, it's super important to submit observations. Helps us out a ton. In addition, you can see that public observations account for about 50% of the total obs. So it's awesome. If you want to find more information on our statistics and kind of what we saw last year, one of my big projects that I've been working on is creating this annual report. So we did one 2 years ago, and then we did one last year. So go check it out. Lots of cool information on it. And just to get into some kind of like upcoming events. So this year, we've got the BTAC Avi Night here, December 4th. We've also got the second annual Driggs Avi Night, which will be December 6th. There'll be a Avi Savvy Avalanche Night in Idaho Falls, if you're living over there. And then we also have the third annual Jackson Moto Avi Night, which will be at the Virginian, December 8th. So go check those out. They'll be super fun, lots of raffles, good information. In addition, we'll be continuing State of the Snowpack talks. So we'll have our normal series at Headwall throughout January and February. We'll also be doing 3 of them over at High Point in Victor. And then what's really exciting, for the first time, we're going to do one down in Melvin in Alpine. So if you're living down in Melvin, definitely come down for that. It'll be cool. Here's another big project that we work on. We do a lot of avalanche awareness classes across all of Wyoming. So this includes Cody, Rock Springs, Burgess Junction, DuBois, and then Star Valley, which is in our forecast zone. Real quick, I'm just going to end with this. And this is kind of the monthly seasonal outlooks that we have. And we can see here we've got kind of this like low pressure system off the Pacific. And this is a rundown of December, January, and February. So we're seeing this kind of shift in weather patterns. And typically, this weather pattern is great for our area. So this is good news. Hopefully, we get a lot of snow this winter. Last thing I'm going to do, I'm going to plug every talk I get. I talk about our snowpack tracker. It's available on our website. As forecasters, this is a tool we use every day. It's super helpful. It's unique to our Avalanche Center, which is, we're super lucky to have this. And essentially what this does is these bar graphs depict 24-hour snow. And so you can go ahead and look to see when it snowed, when we had these drought periods, and it gives a ton of information. I went ahead and threw this up real quick because, looking from a perspective of stepping back, if you were to look at these 2 winters and you would think about persistent weak layers, typically those develop during periods of dry weather, right? Well, interestingly, when you look at this, you see some really long periods of drought conditions. But interestingly enough, this was the winter where we had more persistent slab avalanches. So there's a lot of these small little nuances that get involved. I've been going through a bunch of this data, comparing the two. So at some point down the road, maybe I'll give a talk on that. But I went into a wormhole and found out it's a very complicated process. And that is what I have. So thank you all.
Don't take that. Don't take that. Don't take